All right, let's work on some hyperbolas today. We are talking about hyperbolas, we're finding the foci, the intercepts. We probably will not be working with asymptotes, but we're working on everything else here. So let's start with, you know what? Let's start with what the graphs look like. So the first thing I have, I need a pen. I have x squared over a squared minus y squared over b squared is equal to 1. Or I have y squared over a squared minus x squared over b squared is equal to 1. Now if you notice, before the a square and the b squares changed. In this case, the a square is going to stay. And what do you notice changing this time? See how the x squared is first in the blue and the y squared is first in the red? So now the x and the y's are going to flip-flop, and this is where we learn how to graph the hyperbolas. So the other thing that we need to know is we need to know the foci. So the foci, when it is subtracting, we have a squared plus b squared equals c squared. So let's zoom in right here and let's solve this one. So the first thing I know is I have to go ahead and get that 9y squared to the other side. So I'm going to do that by subtracting. And I know that all hyperbolas and ellipses have to be equal to 1, so I'm going to divide everything through by 144. So what I end up having is x squared over 9, because 16 times 9 is 144, minus y squared over 16 is equal to 1. Now, just like the ellipses, I'm going to graph this in a very similar way. The first thing I'm going to do is look at my x. My x is over 9, so I'm going to go 3 to the right and 3 to the left of the x. Under the y is 16. I have to take the square root, so I'm going to go 4 up and 4 down. And this is the part that's different. With these, I have to go ahead and draw a rectangular shape. From there, I'm going to take all the corners in the center and connect these with what we call an asymptote. So notice this is just a linear line, and I'm making an asymptote. Now, what I'm graphing in purple is actually the graph of the hyperbola. So notice that it starts on x squared, so I'm going to graph it on the x. Notice the vertex goes right there, and I'm going to draw these lines very, 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 very close to the asymptotes, because that tells me how fat or how skinny my hyperbolas will be. So notice the purple part is actually the hyperbola that you are looking for, and when you put this in a calculator, it's not going to look like that. You won't have the asymptotes or the rectangle, so you will have to graph like that. Now, to find the foci, I'm just going to take the two bottom numbers. In this case, they're 9 and 16 and add them. 9 and 16 add to be 25. So I know that C is equal to plus or minus 5. Because that 5 is on the x, because remember those little parabolas, these hyperbolas, just like the parabolas, hug the foci, we're going to go ahead and write that as plus or minus 5 and 0. All right, moving on to the next one. The first thing we have to do is get rid of that 9x squared again. So I'm going to subtract. So I have y squared minus 9x squared is equal to 9. I know that they always have to equal 1, so I'm going to divide everything through by 9. And we get y squared over 9 minus x squared over 1. You don't really have to draw the 1, but you can write the 1, is equal to 1. And this time, we're going to graph again. I know on the y, I'm going to go up 3 and down 3. And on the x, I'm going to go over 1 to the left and to the right. I'm going to draw my rectangle. I think I kind of missed there, so let's try that again. I'm going to draw my rectangular shape and my asymptotes. Now notice on this one, the y is in the front. Do you see how that y is in the front? So my purple hyperbola is what I'm going to graph. And I'm going to graph that along the asymptote. And notice that this time it's graphed on the y. So there we go. We have our hyperbola graphed. We have one on the top, one on the bottom because the y came first. And to find the foci, I'm going to take those bottom numbers. I have a 9, and I think it was a 9. Yep, I have a 9 and a 1. I'm going to add those together. So a squared plus b squared is equal to c squared. 9 plus 1 equals c squared. C squared is equal to 10. So 10 is equal to, c is equal to plus or minus root 10. Now, because plus or minus root 10 is just a little bigger than 3, I know the foci are going to lie here. So we have to write that as a point at 0 plus or minus root 10. And those are the foci. All right, the last question is a little bit different, and I did post a video of what focal radii are and what all these different things of hyperbolas are. And I put that on Canvas if you'd like to watch that in my Canvas if you're in my class. This last example says, find an equation of the hyperbola having foci 0, 3, and 0, negative 3. I like to graph first. Why? I'm a visual person. So I'm going to graph this, and I know at 1, 2, 3, and 1, 2, 3, I have foci. So from here, I know a bunch of things. I know that the center is at 0, 0, and I know that it is a y graph because those foci have to be hugged by the hyperbola. So I know that I'm going to have y squared over something minus x squared over something is equal to 1. In this next part, we don't really talk about this much. We talked about it a little bit with ellipses. It says the difference of a focal radii is equal to 2. Well, what that means is that from the center to the point on top and the point on bottom, there is a space of 2. So what that tells me is that these are 1 away, which means that this would be 1 squared, or in this case, just 1, because I know that 1 squared is equal to 1. So using the equation of foci, I'm going to find the rest of it. A squared plus b squared is equal to c squared. So just a reminder, this is a squared, and this is going to be the b squared. Well, the a squared in this case is 1. My b squared is what I need to look for and put right here where I just drew that box. And my c, well, c was the distance from the center to the foci, which was 3. So I need to write that as 3 squared. So 1 plus what is going to give me 9? Good, b squared is equal to 8. So all I need is that 8 right there. And notice my equation is y squared over 1 minus x squared over 8 is equal to 1. And that's the equation that we're looking for a hyperbola.